Hello everyone. Today we will discuss the multiplier model. Now, the multiplier model is designed to discuss a multiplier process. To discuss this process, we can start with imagining during the business cycle, that is economic activity growing and declining, what happens to the people that are in the labor force, possibly working or unemployed. It's possible if you're unemployed in an upswing, that is, when the economic activity is increasing, you will be able to find a job. Or if you were employed already, it's also possible that you may work for longer hours. You will be able to get more working hours in your workplace. And this means that for the workers, they will be able to bring a larger paycheck possibly to home, and they will be able to have a larger ability to spend money, right? So they would be able to demand more goods and services as a consequence of this business cycle upswing. And the firms respond to this, right? So this will mean that firms will be able to respond to this new demand coming from more workers being able to consume more. And keep in mind, this could be a dishwasher, a restaurant meal, so it's goods, services, tangibles, durables, anything you can imagine. The employment will bring some benefits and additional purchasing power to the economy. And this demand for goods is going to be welcomed by the firms that are going to increase the outputs. Now, the total wage and profits in this process is also increasing, notice, because as the employees or people that used to be unemployed are now facing an opportunity to work more and earn higher income, they have an increase in total wage. And as the businesses are facing more demand in the economy, they will be able to sell more goods and increase profits possibly. So notice this could also happen in the other way, right? So if there were to be a downswing, if the economy was going through a recession, you lose your job, but you also lose your ability to consume. And the companies respond to this with reducing supply. So they will also lay off workers, fire workers, and that would also further reduce the economic activity. So there's always an increased impact of this initial shock of business cycle upswing or downswing that we call the multiplier process. Well, this is obviously a demand side model, and it demonstrates how spending decisions generate demand for goods and services, and as a result, determine the levels of employment and output. So we call this a demand side model, as in the employment and output, unlike the previous examples we had at the wage setting and price setting model, employment and output in this case are determined by the demand side factors. And in the multiplier model, we assume that firms respond to changes in demand by adjusting their outputs rather than their prices. This is going to become a very crucial assumption for this model to work. Notice when there's an upswing in the business cycle and more workers are able to find jobs or work for longer hours and earn more income, and they demand more goods and services, the response from the firms is not to just increase prices, right? So we are arguing that the firms are going to respond by producing more as a consequence of this increased demand. How is that possible? Well, it's possible if you're assuming that firms are not operating at full capacity. That is, firms are able to produce only so much per day, per month, per quarter, annual, year, but they are not using this full capacity. They're producing somewhat less, and that we call capacity utilization. So how much of their capacity they use. Since they're not using their full capacity, when there's an additional demand in the economy, they're able to respond to this additional demand by increasing their production. So that's another key assumption for this model to work. Now it has two components. First of all, we begin by restricting the cases to cases where we have consumption, investment, and inventories only. So we don't have government expenditure and foreign trade in this model. This is just a simplifying assumption. We will extend this model to include government expenditure and foreign trade later. But we start with consumption, investment, and inventories adding up to the national income. So aggregate demand here is going to be denoted with an addition or summation of consumption, private consumption, and investment spendings. Now let's start with consumption. We can write the consumption spending as a function of income, and we will have the aggregate consumption function denoted as follows. as you can see, the aggregate consumption is partly autonomous and partly dependent on the income, right? So Y here is representing the total income. As Y increases, C changes by this small C1, right? So 1 here is an index to denote this is the parameter next to income. And there's this other constant C0 that's autonomous in the sense that it doesn't depend on Y, right? So irrespective of how much income we're talking about, the C0 is a constant consumption demand that people have. And you can imagine in this figure here, when income is denoted in the x-axis and when it's zero, the income, zero income is corresponding to a consumption level of C0, right? So that's the autonomous spend or autonomous spending or consumption when there's no income that we're speaking of. And the slope of this line, as you can see, so how much consumption changes, you can see here on the y-axis, we have the consumption. So it is a function of income and this constant C0. How much income changes affect consumption is measured by C1, right? And that we call the marginal propensity to consume, MPC. That's going to become a very important constant in a second, but for now, we can estimate it or look at it in terms of the change in income. So if you were to increase income, the national income by 10 units here, so 10 billion euros, how much consumption change? Well, it changes by 6 billion euros. So 6 divided by 10 gives us a marginal propensity to consume C1 of 0.6. So it's telling us the effect of one additional unit of income on consumption, pretty much. What about the overall aggregate demand function? Well, that includes, together with consumption, also investment. But unlike consumption, we will argue that it does not include anything that depends on income. And also notice when we speak of fixed investments, and that's what we are covering with the aggregate demand function, we are speaking of new equipment, so spending on new equipment, new commercial buildings, as well as spending on residential structures, the construction of new housing. So this does not include financial investments like stocks and everything else, right? So we are speaking of tangible fixed investment. And that is a part of the aggregate demand together with consumption. So aggregate demand is equal to consumption plus investment. We said investment does not depend on income in this model, at least in this presentation. And consumption is dependent on income partly. There's also an autonomous part. So this is going to represent the aggregate demand here. And using that, we are able to speak of the equilibrium conditions now. So we will speak of a goods market equilibrium, particularly because we will not introduce the labor market in this model so far or yet. And when aggregate demand for output is equal to the quantity of output being produced, the equilibrium is reached, right? So that should come somewhat trivial. So if we are producing as much as what we are demanding, then we are in an equilibrium and the economy will remain at this level unless something exogenous changes. An exogenous change means, or exogenous shock is something that is determined outside the model. So something that is not captured by income level, investments, or the parameters. Something changes and out of nowhere we have a different aggregate demand schedule, and that will mean a different equilibrium level. So unless something like that doesn't happen, then we are at this point A, at which the income is intersecting the aggregate demand. And because in this diagram we focus on product markets, and that's what we speak of that's why we speak of the goods market equilibrium. And notice here the 45-degree line is denoting all the income levels that are equal to the aggregate demand. So as long as we are on this black line here, 45-degree line, we are just looking at a point where the aggregate demand is equal to income, but there's only one aggregate demand function that satisfies this condition, or like our given aggregate demand function satisfies this condition only at one point, and that is point A. Now, what about this equilibrium? So there are different types of this equilibrium. One is going to be a shock, of course, but apart from a shock, it could be that we are simply outside the equilibrium point. So we could be at this point B, where the aggregate demand is not corresponding to an income level. So at point B, we see the output is greater than the aggregate demand, right? So the corresponding output is more than aggregate demand. That means we produced more than what is demanded in the economy. And this will also mean that we will have a stock of unsold inventory, right? So the companies are going to produce, but they won't see demand, so they will have to generate inventories, and that those inventories are going to tell the companies, the firms, that they should reduce production, right? So as a consequence of this gap here, they will cut production. That will mean less employment meaning less demand, meaning less production. So that is going to push the economy back to the point A. On the contrary, we could be at this point C, where we have more demand. So here output is less than the demand. So we have more demand than what is produced, as you can see here. And that will mean that firms are going to eat up their inventories, which is going to signal them they should actually produce more. And to do so, they need to employ more people and push it all the way up to point A back again. So this intersection of aggregate demand and the income 45-degree line. Now the general equilibrium in this case, or the goods market equilibrium, is telling us something about the national accounts overall, right? So we have captured this equality here, or equivalence. And we saw that this is implying that the national accounts identity is as follows, which is income is equivalent to consumption plus investment plus the inventory, or changes in inventory. And the reason this holds is, notice C plus I is our aggregate demand, right? So if it is equal to the income, then there is no inventory at all. But as long as the aggregate demand is over or above the income generated in the economy, then we will see changes in the inventories. So this equality, or if you will, equivalence, is always going to hold, particularly because there's inventories added here. So as long as we are in an equilibrium of aggregate demand equal to income generated, we will have inventory investment is equal to 0, right? So inventories are going to be equal to 0 when aggregate demand is equal to income in the economy. Now, let's talk about a different type of deviation from the aggregate demands, or the goods market equilibrium. So let's say we start with point D this time, right? So initially we were at AD1, and that was our aggregate demand intersecting the income level here at point D. And we are seeing a decrease, a cut in investment by 15 billion euros. So the aggregate demand is decreasing here, shifting downwards, becoming this AD2 function, right? So investments initially were I, they become I prime, so they reduce by 15 billion euros, and now we are here at point E. Now, there is less demand in the economy, and we have larger and larger inventories occurring. The companies see this as a signal, and they also cut production, and so they reduce outputs from D to E. We now move to from E to F, right? So this initial 15 billion euros of decrease is now followed by another 15 billion because the companies saw less demand, piling up stockpiles or inventories, and they decided to reduce production to get rid of the inventories. Now, that is a part of the process, but the cut down in production will mean that there's going to be a cut down in the employment as well, which means households' income is reduced, and we will have a reduced consumption demand, which again is going to have an impact on the production side, because observing less consumption demand, producers are going to produce even less. So first we see this impact of reduction in consumption. In the previous example, we found a C1 of 0.6. So the impact of 15 here on the impact of the total reduction so far is going to be multiplied with the 0.6 to show another $9 billion decrease in consumption demand, which the firms read as decline in demand. So they cut down production even more, which is generating less income, and then less demand, less production, less demand, less production, and we reach out to this point Z eventually. And the crucial part here, why we call this a multiplier model, is because we just faced this initial shock this reduction in investment by $15 billion, but the total reduction in income turns out to be $37.5 billion. So the total impact of one unit change was more than one unit. How do we calculate this? Well, here we have the $37.5 billion decrease in total. We'll just discuss how to calculate this total. But if you're able to find that total, you divide it with the initial change and you see the change by 2.5. So that one unit change in investments caused 2.5 units of change in the total expenditure. So it is this multiplier process that gives the multiplier model of aggregate demands the name, right? So why we call it a multiplier model? Because we see a multiplied impact of the initial change. What is this model, or what does it do? So we start with a fall in demands that's leading to a fall in production and an equivalent fall in income that's followed by the multiplier being the sum of all these successive decreases in production and production adjusting to demand, and the multiplier in this model becoming always greater than 1, right? So the initial impact is always leading to a larger cumulative impact. And for the multiplier process to work, we already emphasized this. There are some crucial assumptions that needs to hold. So one is that the spare capacity and fixed wages need to be there. That is, when the households are increasing their demand or decreasing their demand, the response from the firms need to be a supply response. So if, for example, we were to have not a decrease in investment, but an increase in investment, that's going to show a decline in the overall inventories. The companies should be able to respond by increasing production. So they should be able to have the ability to just change the production as well without investing further into generating capacity first. That is like an embedded, if you will, assumption to this model to work. And if there was no spare capacity, some of the increased spending would have translated, as you can guess, to price increases and wage increases. And that's, you know, the inflationary effect as opposed to changes in the overall income. Now let's talk about the analytics, what this model looks like, how we calculate multiplier after all. So we said that the at equilibrium income is determined with this aggregate demand. And it's composed of the autonomous components, so C0 and I, and a part that depends on income, C1 times Y, right? So we have Y here, let's get them together. We have Y times 1 minus C1 is equal to, since this one left to the left-hand side, we have C0 plus I left on the right-hand side. Divide both sides with 1 minus C1, so you obtain Y is equal to this constant divided by 1 minus C1. This is going to be crucial because this says something very interesting. In equilibrium, or goods market equilibrium, income, the national income, is a function of autonomous demand, that is C0 plus I, divided by 1 minus C1, which is again a constant, right? So autonomous, these are constants, and 1 minus C1 again is a constant. So we are able to find the equilibrium level of income, and it is a function of the autonomous demand multiplied by a function of the marginal propensity of consumption. So if I were to give you the C1, we found it to be 0.6. And if I were to tell you the initial autonomous consumption demand is 10 and investment is 22, then you would be able to find that the equilibrium level of income in this nation is going to be 80 billion euros. Now let's rewrite this equation in a particular way. Remember, the equilibrium level of income was equal to C0 plus I divided by 1 minus C1. So let's rewrite 1 over 1 minus C1 as K, right? So K constant times this autonomous demand is going to tell us the equilibrium level of income. So this explains why we call this K a multiplier, because you can check that when C1 is equal to 0.6, K will become 2.6. This may be familiar from what we found a second ago. A decrease of 15 billion euros led to 27.5 billion euros, and the ratio was 2.5. And indeed, if C1 is equal to 0.6, you plug this into here to find 2.5. So if the C1 is equal to 0.6, it gives you a particular a multiplier constant as given as 2.5. There's another reason that we can see that the multiplier effect is embedded or reflected by this K constant. So if income is given as Y, the change in income, so we denote the change with delta. I notice this is not the percentage change, this is just change. So from one moment in time to another, how much income changed is given as delta Y. And let's say there's a change in income denoted with delta Y and caused by a change in investments. So let's say we had the initial investments I, and we add a change factor to the investments denoted by delta I. So the new income is going to be Y is equal to K times C0 plus I. So far, so good. But then we say it's changed by this delta I, right? So we add this delta I amount. Previously, what the income was, well, it was Y, which is K times C0 plus I. So the change, the difference is going to be the new income minus old income. You can see K times C0, K times C0, there's a minus here, they cancel out. We have a K times I, we have a K times I, there's a minus here, they cancel out. So we are left with K times delta I. So the constant, the multiplier times the change in investments is going to tell you how much the income overall changes. So this K constant, which is a function of the here marginal propensity of consumption, is going to pretty much tell us what the process of multiplier looks like. Now, is there a way to calculate this K and marginal propensity of consumption, actually derive it, if you will? So we consider the effect of an increase in investment by 15 billion euros previously, and we can summarize our findings from the multiplier diagram by showing some algebra, so why and how we obtain these multipliers. And to get the multiplier, we can calculate the total increase in production after n plus 1 rounds of the process. So remember, when there was an initial change in the income by 15 billion euros, it then followed with another 15 billion change in production, which is followed by another 9 billion in consumption, which is again followed by 9 billion change in production. So notice these are taking time, right? There's iterations. So let's say we have 1 step, 2 steps, 3 steps until n plus 1 steps, so rounds and rounds of this process going on. So we are able to say in the first round of this process, the initial decrease was 15 billion euros, right? So that's we know. The second round increase, or let's say the change followed by the first change. So in this case, we are speaking of 15 billion euros of increase in investment. The second round is going to be C1 times 15 billion euros. The third is going to be the second times C1. So C1 times 15 billion euros. And notice C1 and C1 are just constants, the same constant, so we get the square of the same constant. I want you to notice a crucial pattern here. The first step, we don't have any C1, so we could think of that as C1 to the power 0, which is equal to 1, times 15 billion. So first step, the power is 1 minus 1. The second step, we have here C1 to the power 1. That says 2 minus 1. The third step, we have C1 to the power 2. So 3 minus 1, right? So at each step, this power here is the number of step minus 1. So in n plus 1 rounds, we will have C1 to the power n, right? Because we have n plus 1 minus 1 is going to turn this into C1 to the power n. Now, all right, let's see what it looks like. We have this finite number or finite summation here. So the first step, second step, third step to the n plus 1 step. And we can see 15 is included in each one of these couples. So we get the 15 parentheses here. Take the 15 parentheses. So 15 times 1, 15 times C1, 15 times C1 squared. So these two are equal to each other. This is the total increase in demand and production after n plus 1 rounds. Well, what do we know about this? We want to show something a bit tricky to show. We want to show that the total sum in the brackets here reaches to a limit of 1 over 1 minus c, as n gets large, right? So as we give it more and more and more time, it's going to turn into 1 over 1 minus c. That's what we argue. So let's say this summation here, except for 15, the terms in the brackets, let's call that constant k, right? And let's multiply both sides of this equation with 1 minus c1. So this is going to turn into k times 1 minus c1, as you can see here. And this right-hand side is going to turn into 1 plus c1 squared plus goes on, times 1 minus c1. So the parentheses times 1 minus c1. Now, can we open this parenthesis here up? We can. We have 1 times this whole bracket, which is going to be itself, minus c1 times the whole bracket. Well, notice c1 times 1, c1 times c1, c1 times c1 squared is going to turn into the first term c1, the second term 1 plus 1. So the term is going to be squared. And we have the 2 plus 1 more c1, so c1 cubed, and it goes on, right? So the last term here was a c1 to the power n times c1 is going to turn into c1 to the power n plus 1 here. So can we make something out of these two brackets or these two terms? Well, we can. As you can see, we have 1 here. There's not much we can do with that, but we have a c1 minus c1. We have a c1 squared minus c1 squared. As you can guess, there's a c1 cube here. There's a c1 cube again minus. So almost all the terms here are gone except for the first one, and all the terms here are gone except for the last one, which gives us 1 minus c1 to the power n plus 1 is equal to k times 1 minus c1. Now, if we divide both sides with 1 minus c1, so we get rid of this 1 minus c1 here because we divide it by 1 minus c1, and we divide this last term we obtained with 1 minus c1 too. Since they are equal to each other, this should hold. Now we have k is equal to 1 minus c1 to the power n plus 1 divided by this constant here. Now, I want you to notice something. We said the marginal propensity of consumption is less than 1. This is just to say, as you consume more or as you earn more, you are consuming not the entire fraction, but a part of the total income piece by piece by piece, right? So that's why we are able to assume that the marginal propensity of consumption is going to be able to less than 1. And using that information, we can say something interesting. As you take the power of C1 to 1, then 2, then 3, then 4, imagine this is a number less than 1. It's a fraction. So as n goes to infinity, this will go to 0, right? So imagine you're looking at 1 over 2. If you take the square, 1 over 4, cube, 1 over 8, fourth power, 1 over 16, it gets smaller and smaller and smaller. And as n goes to infinity in the limit, this whole term here becomes 0. So we end up having k is equal to 1 over 1 minus c1. So this is just to show that the multiplier is equal to, in fact, 1 over 1 minus c1 at the limit. And we are able to say, using the marginal propensity of consumption 0.6, that the multiplier for this particular example is going to be 2.5. So that's how we found the multiplier effect. So for any instance where you have some information about the marginal propensity of consumption, you should be able to use a pen and paper and simply say, well, if we were to increase the investment by this much, given the marginal propensity of consumption, this is the multiplier. So the total effect is going to be that much, right? So you can make that calculation using the multiplier formulas. Now let's expand our model to include government and net exports. We said output is equal to aggregate demand, so income is equal to aggregate demand. And what is aggregate demand? We so far had consumption and planned investment. Now we add government spending and net exports as well. Well, that's going to require some tweaking. First of all, consumption now is going to change because for government to spend, they need to get this money from somewhere. So let's say they're getting that money from taxes, right? So in our model, household consumption depends on post-tax income in this case, and the government taxes the people by a fraction t. So 1 minus t is what's left to you to spend. So now our consumption function is going to look like the autonomous spending plus c1 times y. That was our income-dependent part of the consumption, but that's now also reduced by the taxes. So whatever is left post-tax is affecting the consumption decision. Investments, now we are expanding a bit. It was completely autonomous. Now we are saying there's an autonomous investment again, but there's a part that depends on the interest rate. So as interest rates go up, investments go down. Why? We are assuming A1 to be a positive constant, and minus sign here says higher investments or higher interest rates reduce investments. The government spending, much of the government spending is on general public services like health and education. This is well proven in pretty much any government out there. And the government spending does not change in a systematic way with changes in income, right? So most of these services on health and education, they are not necessarily becoming more available and better with higher income or cut down with lower income. A basic level needs to be provided to people under all circumstances. So we will say it's not going to be a exogenous constant in the model. For net exports, we can add something. So exports are going to depend on the income of the rest of the world, so we can't do anything about that. But our imports are going to depend on how much we earn. So let's say imports are a function of Y. So as your income goes up, you import more. That's measured by this M. So this M represents something similar to this C1. How much your imports go up as you have more income is denoted by this M times Y. So our aggregate demand now is going to look like the addition of all these terms. Here we have C, the consumption, and notice it's a function of the autonomous consumption, the post-tax income times C1, and then we have the investments. Now it's a function of autonomous investments minus the part that depends on the interest rate, plus a government expenditure, completely exogenous, and plus the net exports. Exports depend on the rest of the world's income, so we don't make it a function of our income, but our imports depend on our domestic income, so we have this effect coming from M. So there are different types of effects here. So changes in autonomous consumption, government spending, these are going to lead to parallel shifts in the aggregate demand up and down because they are autonomous and constants. An increase in exports or autonomous investments is also going to have a similar upwards, downwards shift type of effect. Now, let's talk about what are going to be the impacts of these policies. What if the government's spending more? Well, this is going to be an interesting example. Initial aggregate demand here is given as the function that we had before, and the government expenditure moves to G prime. Before it was G, so the new aggregate demand is pushing us to this higher level. And notice the idea here is that with higher demands, producers realize they are losing their inventory, so they should be producing more. And to do so, they're employing more people. Well, employed people consume more, and the producers start thinking, well, they should produce even more, and it takes you to this new aggregate demand intersection with the production, and you end up having a new equilibrium here, so higher level of output. Another example could be a rise in the interest rate. Well, notice interest rates initially was R, it becomes R prime, so it increases, and a higher interest rate with A1 being a positive constant will mean a reduction in aggregate demand. Why? Because we have a negative sign here. So the aggregate demand shifts downwards. And the idea here is that we have higher interest rates, lower investments, and again, whoever's producing investment goods, capital goods, they notice there's less demand for their goods and services, and they start firing people. Well, they cut down production. Those people won't be able to consume, and there's going to be less demand in the economy. That's going to lead to even less production, and we are moving to this lower equilibrium. So higher interest rates tend to reduce economic activity, and lower level of output comes the consequence of that. A fall in tax rates. So let's say we are looking at a case where we have lower taxes in the economy. Notice it's somewhat different than the previous cases because we are seeing a slope parameter than an exogenous constant. So a fall in the tax rates increases the size of the multiplier because more household income is available to spend on goods and services. So if everything else is the same, ceteris paribus, the aggregate demand curve becomes steeper, meaning that the indirect effects of the changes in C0, A0, and everything else on output and employment are going to become larger. So we have a higher new equilibrium as a consequence of this change in the tax policy. Similarly, we can look at an impact of the increase in M. That is, if we were to be responding to changes in income in a more sharper way, if you will, to import more goods and services, then what will happen is a reduction, if you will, in the slope, and now we have a lower, if you will, aggregate demand level. So a rise in the marginal propensity to import decreases the size of the multiplier because less household income is spent on domestic goods and services. The crucial part here is not the consumption. In some ways, you may think, well, why M acts differently than C? Well, as you can see, it's reducing the consumption within the or demand for the domestic goods. So that's pushing the equilibrium to this lower level. Now, let's look at the full model that we have just described and what the multiplier is going to look like in that model. We said the aggregate demand is composed of consumption, investment. Now it's a function of interest rate. That's why we put a parenthesis here. This is not multiplying investment. This is saying investment is a function of interest rate. Government expenditure, a constant exogenous, and exports minus imports. And we said consumption we can write as this, right? So this is our autonomous consumption plus the post-tax consumption times the marginal propensity of marginal propensity to consume. And then we have the autonomous investment minus the part that depends on the interest rates. Government expenditure, exports minus the imports, which is a function of income and the marginal propensity to import. So we have written the investments as a reminder that investment is a function of interest rates, as we said, and we rearrange this equation. So let's say we are in an equilibrium point where income is equal to aggregate demand. Well, the problem then would be we have the consumption here is a function of income, and here also we have the import as a function of income. We can take both those terms to left-hand side. So we initially have this equation. So income is equal to aggregate demand. Take the terms with y to left, you end up having y times 1 because we had y here already. And this term here goes to left, becomes a negative. With the y parentheses, it becomes c1 times 1 minus t. We have a minus my here, so that becomes a plus m here. So you divide both sides with this term in the brackets. So y is equal to that term in the bracket, so 1 over that, times whatever is on the right-hand side. This is a demand that doesn't depend on income, right? So we have multiplier and part that doesn't depend on income. So we call it multiplier K multiplier. And the multiplier in this case is smaller when we introduce the government and foreign trade. Why? We can tell that by showing that the multiplier that we just derived here is equal to 1 over this constant here is less than the case that we had before where there is no government. So T is 0. And C1 is the only part that we have. Again, import doesn't exist. Why do we have this inequality holding? Because you can see this part here is larger than 1 minus C1, right? So we had 1 minus C1 previously, but now we have 1 minus C1 plus C1 times T plus M. So we are dividing 1 with a larger number in this case, which leads to a smaller multiplier. So to illustrate this point, suppose previously we had C1 is equal to 0.6. But now we have taxes of 20%, so 0.2, and marginal propensity to import. So M is equal to 0.1, 10%. And if you put these numbers in, you will see the new multiplier is 1.6. It was previously 1 over 1 minus 0.6 was equal to 2.5, right? So our multiplier decreased as a consequence. I will continue with consumption and investment in a new video, next video.